This video is going to review some basics of rational functions, which you should know from Algebra 1 and Algebra 2. So first we're going to start with simplifying. First of all, notice that I'm simplifying rational expressions, which means there's no equal sign or equation. Whenever you simplify, you want to factor everything completely in the numerator and the denominator as much as possible. Then you are going to cancel or divide any common factors, and then you are going to rewrite your expression. So if you want, pause the video and try each one on your own. In number 1, I have a trinomial in the numerator that I'm going to use AM on to factor. So 1 gets a plus, 1 gets a minus. I'm looking for factors that multiply to 6, add to 1. Bigger number comes first, so it's minus 3 plus 2. In my denominator, I have a binomial with a GCF, so the 5x is going to come on the outside. When I divide each piece by the GCF of 5x, I'm left over with x plus 2. Now I'm going to cancel, which is really dividing. So x plus 2 over x plus 2 divides out to give you 1, and then I rewrite, so I have x minus 3 over 5x. Remember that I have a binomial in the numerator, which is attached, so you cannot cancel those x's. For number 2, my numerator is a binomial with a GCF. 2 times 4 minus x. My denominator is going to be a trinomial for AM, x minus 4, x minus 4. Notice how these seem very similar, 4 minus x and x minus 4. They're the exact opposite. So you are going to divide or cancel them, but they become a negative 1. So this becomes negative 2 over x minus 4. So if I have something like a plus b over b plus a, that's going to give me 1. Addition is commutative. But subtraction is not, so these divide to a negative 1. Just something to keep in mind. Let's move on to adding and subtracting. So when I'm adding and subtracting, remember that you must have a common denominator. Once you have a common denominator, you can combine your numerators, and then you always want to factor, cancel, simplify at the end whenever possible. So looking at number 3, I have common denominators already, so I'm going to rewrite this as a single fraction because my denominator is x plus 5. Notice how I put my second binomial in parentheses because it's a subtraction sign. So you need to subtract each piece. So I have 2x plus 3 minus x plus 3. Combine like terms in my numerator, I have x plus 6 all over x plus 5. Nothing can be factored, nothing can be canceled, nothing can be simplified. Number 4, I do not have common denominators, so I need to find an LCD. So my LCD is going to be x times x plus 3. Typically, to find your LCD, you are going to multiply your two denominators together. Now I'm going to multiply each piece by what's missing. So my first fraction is missing an x plus 3, top and bottom, because then I'm essentially multiplying by 1. My second fraction is missing an x, so top and bottom get multiplied by x. So I have x plus 3 over x times x plus 3 plus x over x times x plus 3. Denominators now match, so I can keep them and write everything as a singular fraction. X plus 3 plus x. Combine my like terms. I'm left with 2x plus 3 in the numerator over x times x plus 3. You could, of course, distribute out your denominator, but if you make a mistake distributing, that would be penalized, and you don't want to have to undo it by factoring again at the end to see if anything can cancel. So whenever possible, leave your denominator in factored form. Lastly, we're moving on to rational equations. So notice how I now have an equation. There's an equal sign in my question. There are two different methods for solving rational equations. I'm going to show you both, one for number 5, one for number 6. Your choice as to what you want to do. So I'm going to treat number 5 to multiply by what's missing, which is similar to adding and subtracting. So I'm going to use an LCD here of 12y. So my first fraction is missing a y. So I'm multiplying both top and bottom by y over y. My second fraction is missing 12, so top and bottom get multiplied by 12. And then on the right side of the equation, I have a 4. I want it to be 12y. So what do you need to multiply by to get from 4 to 12y? 3y on the top and the bottom. So I now have y over 12y plus 12 over 12y equals 3y over 12y. Once your denominators are the same, because I have an equation, I can eliminate them. So I have y plus 12 equals 3y, which is now a basic linear equation that I'm going to solve. And I get y equals 6. You always want to make sure when you're solving that your answer is not an extraneous solution. It would be an extraneous solution if, when I substitute back into the original function or the original equation, my denominator is 0. So if I plug 6 back in, I'm not going to get 0. Of course, if you wanted to check, 1 over 12 plus 1 over 6 equals 1 over 4. If it's a calculator question, you could, of course, use your calculator to check, or if it is not a calculator question, going to have to do some old school math here. 1/6 is the same thing as 2/12. So this becomes 3/12, which reduces to 1/4. So my answer is correct. So I multiplied by what's missing to use that method to solve number 5. Last question, number 6, we're going to multiply by an LCD and use that method to solve here. So the first thing is I'm going to rewrite my binomial, difference of two perfect squares, as x minus 5x plus 5, which is actually going to be my LCD. So when you solve using the LCD method, you are going to multiply every single piece of the equation by the entire LCD, not by what's missing. I'm going to multiply x plus 5, x minus 5 over 1, x plus 5, x minus 5 over 1, x plus 5, x minus 5 over 1. So in my first fraction, the x plus 5 and the x plus 5 divide out. I'm left with 2 times x minus 5. In the second fraction, the entire binomial pairs divide out, so I'm left with 20. And on the right side of the equation, nothing cancels or divides out, so I'm left with x squared minus 25, or of course you could write it as your two binomials, up to you. Now I have a quadratic equation that I need to solve. Remember, when solving a quadratic equation, you always want it equal to 0 and in standard form in order to factor and solve. So I have x squared minus 2x minus 35. Using AM to solve, x minus 7, x plus 5. So x equals negative 5, x equals 7. Once again, check for extraneous solutions. X minus 7 works, but if I take my negative 5 and I plug it back into my original numerator, this would be negative 5 plus 5, which would give me 0, which is undefined and not allowed. So this part of my answer rejects because it is an extraneous solution. So my overall answer is just x equals 7.